Hey everybody, we're going to move into the second section of Unit 10. Now, I'm not exactly following the exact method of the book. I'm just doing what I think are best practices, and just so you know, my dog just got home from her walk, so she's probably going to fly up here on the couch with me, so just be prepared. So before we start, we're going to go ahead and do our perfect squares up to 30 again. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. 6 squared is 36. Feel free to pause the video and make your own list. 7 squared is 49. 8 squared is 64. Let's see how many I know. 9 squared is 81. 10 squared is 100. 11 squared is 121. And just so you know, when you take the keystones, I'm going to ask you to go, before you even start number 1 on the keystones. Nate, the dog's eating the cat. I'm going to ask you to go to 15 squared on the keystones. So 12 squared is 144. 13 squared is 169. You don't have to have these memorized for the keystones. You can use your calculator when you make your list on the keystones if you don't have them memorized. Let's see. 15 squared is 225. 16 squared is 256. Now I'm getting a little hesitant. 17 squared is 289. 18 squared is 324. 19 squared is 361. 20 squared is 400. Uh-oh, here's where it starts falling apart for me. 21 squared is 441. 22 squared is 44. Let's look. And once I start hesitating, I'm going to double check them over here. All right. 23 squared. I'm not even going to guess anymore. 529. 24 squared. Sorry about my dog. 576. That one I think I might have been able to guess. 25 squared. I do know that one. 625. 26 squared. I think it's 676, but I'm not gonna. Yep, I was gonna say I'm not gonna guess. I'm gonna verify when I don't know. 27 squared. This is recording, right? 729. Yeah, okay. 28 squared. And let's see, we got 784. And 29 squared. So hopefully you don't have my kids' music too much here. I told them I'd shut the door because I knew it could get annoying. 30 squared is 900. All right, so when we develop these notes, I'm going to be doing that just so we get used to memorizing our perfect squares. Now, when I say our perfect squares, I mean all these numbers highlighted here in yellow. Okay, those are very important to us. So we're going to review what we did last lesson. So let's say that we're given something on our list. You know how 16 is on your list? So the square root of 16, the answer is just 4. Okay, so I have the square root of 16 equaling 4. There's no further simplification. Now remember, 48 was not on your list, so you go as close to 48 or half of 48 as you can, and that's going to bring us to about 36 or 25. So you do 48 divided by 25, 48 divided by, what's next, 16, and you get your final answer. So there's your 16 and your 3. Remember how we talked about you do your perfect square and then your leftover. The square root of 16 is a 4, and the square root of 3 left over. So the answer would be 4 square roots of 3 when it's simplified. Remember, you have to find the biggest one. So then we do again with 28. So we go about 16-ish. We'll do 28 divided by 16. That doesn't work. 28 divided by 9. That doesn't work. 28 divided by 4 is the first one that works. So that's why we picked 4 and 7. 4 was the first one that works. 7 was what we got as our answer. So the square root of 4 becomes a 2. So we say 2 square roots of 7 at the end. And then another one is 120. So on our list, we can start like 64. So you can do 64, doesn't work. You can do 49, is not going to work. You can do, I'm missing my 1. There it is. Let's see. What did I just do? 36, doesn't work. You can do 25, doesn't work. You can do 16, doesn't work. And you can do 9, doesn't work. And then you finally get down to 4. And 4 is actually the biggest perfect square that works. And when you divide, you got a 30. And so you take the square root of 4 and you make it a 2. And then you have 2 square roots of 30 left over at the end. All right, it's your turn. We're also going to review some Algebra 1. Now today you will be multiplying and dividing. The dog brought me her toy. So you're going to multiply and you're going to divide the square roots. And so the one way that's going to work all the way is you need to make sure that you multiply and divide first. And then you're going to reduce the way that we did up here. So when I say reduce, I mean reduce the way that we did yesterday. All right, so we're just working more with square roots here, okay? So 121. Well, I am going to get my list. It's a list that I've developed before. And I'm going to bring my list down to this page. This is the same list I developed and I had yesterday. And I want you to see that 121 is on the list. 121 is perfect. So when it's perfect and when it's on the list, you just take the square root of 121. There it is. And my answer is 11. Nothing more, nothing less. All right, so now when we move to 150, 150 is not on my list, right? So this is still review. So I'm going to go to like the 80s, okay? So I'm going to start with 81. So if I do 150 divided by 81, that doesn't work. 150 divided by 64 doesn't work. 150 divided by 49 doesn't work. 150 divided by 36 doesn't work. 150 divided by 25, there it is. That one's going to work. Okay. So this is going to be, what did I divide by that worked? I divided by 25 and I got 6. So instead of leaving it as 150, I write it as the product of its factors. The reason I do that is because the 25 becomes a perfect 5 because the square root of 25 is 5 and the square root of 6 drops behind it. So all of that was review. And now it's time to move on to the new stuff. Now, maybe some of you are like, oh, I know the square root is 49. This is perfect, right? So it's like just a perfect 7. That is correct. And the square root of 2 is left over. That's totally fine, and that works out when it's perfect. However, today I'm going to be encouraging you to multiply together first, just so you have one step that works all the time, and then find what goes into it. In this case, when you find it, it would be a 49 times a 2. So this one ends up being the same thing, which is your 7 root of 2. So there's the process of why it works. When it's on your list, it's like they already did the job for you. But that's not always going to work. Okay, so I'm going to show you 2 methods of doing this one. I really hesitate with the first method because I think sometimes you're going to use it and think that you did it right and be done with it. Now, 81's on your list. Like, you can do the square root of 81, right? It's a 9. And then the square roots of 12 would drop down. You're going to think that you're done. You're not, though. So I don't always recommend this method because you would have to break 12 apart to 4 and 3. So the better method that works is multiplying, because I don't know about you, but most students like one method that works all the time. So I will highly encourage you to multiply them together. So see how I did that? I multiplied them together. What I end up getting, 972. And now we do what we've been doing. Like, so we go back to like what we did yesterday and we figure out what goes into 972. And you might say, well, doesn't 81? Yeah, but it's not the biggest one. So I'm going to do 972, and I'm going to divide by, I'm going to start pretty big. I'm going to go to like 484. Does not work. 972 divided by, 441. Does not work. 972 divided by 400. Will not work. 972 divided by 361. It does not work. Now let's try 972 divided by 324. Sorry, it's the dog. And I get 3. The dog, she just brought me the toy. Okay, so I'm going to break this down into my 324. So I'm just applying the rules that I did yesterday times the square root of 3. Well, the square root of 324 is 18. And then the square root of 3. So our final answer is 18 square roots of 3. So I hesitate doing it the first way because that is not, remember how I said it wasn't done? That's because the square root of 12 has inside of it a 4 and a 3. So you would have to do 9 times 2 with the square root of 3 and then finish with 18 square roots of 3. But I want you to see how much longer of a process this was. So if we simply just take our time and multiply them together at right off the bat, and we multiply them together right off the bat, I think it's going to simplify the process and not bring in a ton of different extra rules. So I want to do that again on this one. So I really don't want you just to be like, oh, yay, this is 6 and this is 18 and call it a day, because 18 can still get broken down. So I would highly encourage you to multiply them together first. So put them together. So what is 36 times 18? So I have 648. Now I want you to go to your list and do what we did. So there's just one extra step from yesterday. So today I want you to put them together, either by multiplication or division, by whatever it says. Okay, so now we run through the process that we ran through yesterday. 648 divided by something in the 300s. I think it's actually 324, isn't it? Perfect. So 324 is where I would start on my list because it's half of it. And it worked. So now I'm going to do the square root of 324. Oh, that's funny because that's what we did last time. What did I get in the calculator? Square root of 2. So that's going to be 18 with 18 square roots of 2. So again, you're going to multiply them together first, and then you're going to reduce them. Now, this one might be a little bit easier to not multiply them. You could just do simple 5 times a simple 6 is a 30. Okay, but what's going to happen is you're going to start using rules that don't apply all the time. So just multiply them together. You get 900. 900 is on your list, right? You see it over here. And the square root of 900 is a simple 30. So you're going to multiply them together first, and then you're going to reduce them the way that we did yesterday. Now let's do 10 and 20. So I got 200 when I put them together. So I'm going to multiply them together first, and then I'm going to go to my list. Well, what are we going to use on our list? Let's drag this list down. I would always encourage you to go about halfway. So I'm going to do 200 divided by, well, that's going to be 100. And that's going to work. So I'm going to break this down to 102, which makes 10 square roots of 2. And so I have 10 square roots of 2 is my final answer. Okay, let's go up here. What do we have going on here? We have another multiplication one. So again, I do not want you to, I really hesitate to have you reduce them first. I really want you to multiply them together first. So whatever I can do to convince you that I'm right, just take it for what it's worth. Multiply them together first and then reduce them. I don't know why I'm having so much trouble moving this. Good enough. Okay, here we go. So we're going to multiply them together first. We're going to do 7 times 21. We're going to get 147. Now I'm going to make my way through my list. So maybe in like the 80s. So 147 divided by 81. No. 147 divided by 64. No. 147 divided by 49. Yes. So this is 49 and 3. Square root of 49 times the square root of 3. The square root of 49 is a perfect 7, and the square root of 3 drops down. Final answer is 7 square roots of 3. One last time for good measure. You're going to multiply them together to join them to be 1. So you want to join them together. So the square root of 1200. So let's see. I'm going to start around 576 then, okay? So 1200 divided by 576. That doesn't work. So I'll draw an X through it. 1200 divided by 529. That doesn't work. 1200 divided by 484. Nope. 1200 divided by 441. Doesn't work. 1200 divided by 400. There's your ticket. So I'm going to have 400, square root of 400 times the square root of 3. So we didn't like it like this. We had to rewrite that one, and we get square root of 400 times the square root of 3. The reason is the square root of 400 is a 20, and the square root of 3 drops down. So we have 20 square roots of 3. And then we move on to the next one. Okay, so in this one, we're going to divide first, okay? So this one we're going to divide first to get a single square root. And we end up, and then we use our process steps from yesterday. So 363 divided by 3 is 121. So I have the square root of 121, which is a perfect square root if you look here on the list. The answer is just 11. Nothing more, nothing less. Let's do the next one. So we're going to divide first, okay? So we're going to do, so instead of multiplying on this one, we're dividing. Okay, so what do we get? Square root of 16 then? Well, the square root of 16 is just a plain 4 because it was on our list. It's a perfect square. The square root of 16 is 4. Okay, now we're going to divide again, but it's going to be different. So 3,000 divided by 5, and we get 600. So when I divide here, I end up getting the square root of 600. Now I need to go to my list and figure out what two square roots am I going to break that into, because 600 is not on my list. Oh, let's see. So what goes into 600? I mean, I know my answer, but it would be we would start in the 300s, right? So let's do, or in the 289s. So let's do 600 divided by 289. Nope. 600 divided by 256. I'm making my way down the list. So what do we try? No. Now we're going to do 600 divided by 225, and the answer is going to be no again. 600 divided by 196, and the answer is still going to be no. 600 divided by 169, the answer is going to be no. 600 divided by 144, and the answer is going to be no. 600 divided by 121, and the answer is going to be no. And finally, we make our way down to 100, and we've got it. So we're going to break 600 apart into 106. The reason is because the square root of 100 is a perfect 10, and we have 10 square roots of 6 when we bring that one down as our final answer. So we divide and reduce. So we're going to do it again. 560 divided by 7. So this one's we're going to divide first. And what do we get? Just the square root of 80. Now we need to go to our list and figure out what goes into 80. So now we apply yesterday's rules. So let's see, where was I at? I'll try 49, okay? So let's drag this down. Okay, there it is. All right, so I'm going to try 80 divided by, I'll try 49 to start with. And the answer is no. 80 divided by, what's after 4? 36. The answer is no. 80 divided by 25. The answer is no. 80 divided by, what's next? 16. And the answer is yes. Good. So a lot of kids actually just go straight to 4. They bypass 16. So that's going to be the square root of 16 with a 5 turns into 4 square roots of 5 at the end, because the square root of 16 is 4. One more of these type. I got to make sure I see the number. Okay. So I'm going to divide that. So I do 100 divided by 25. Oh, not that number. 100 divided by 25, and I get a perfect 4. So when I divide, I get a square root of 4, right? Well, that's okay because the square root of 4 is a perfect square, and the answer is just 2. Okay, see that right there? The square root of 4. So the answer is a perfect 2. Some kids will write like 2 square roots of 2, but that's not how it works. When it's a perfect square, you just write its final answer. Kind of like we did here and here. So these were all perfect squares, which is why we just wrote the answer. Even this one, we got a perfect answer. All right, now we're going to go back to the class before me, because you do need to have these remembered on the keystones. What is the domain and the range? So remember, domain is left to right, and range is the lowest point. So I'll write down to up, okay? So let's do left to right. So I'm going to draw a TV box around this. So how wide is your TV box? Well, I see my TV box starts at -5 on my x-axis, and it goes to +1 on my x-axis. So here's the -5 I'm talking about. Here's the +1. And it's open at -5, so I'll just do that symbol. And it's closed at +1, so I'll do that symbol. My TV box, the lowest value is -3, and the highest value is +1. So I'll do, it touches +1, because it does have a closed dot, even if it's over here. And it actually does touch at -3. It just graces it, but it does touch it. So those are both equal, less than or equal to, because it touches those values. What is the inequality that represents the graph above? So I always look for my y-intercept first. So that's my -1. That's the number in the back. So it's like we're doing mx and b. And since this is shaded under, I use less than. And since it's broken, I do not put the equal to sign. So let's do y is less than. Let's figure out what the slope is. So I notice that this one's going up let's see, here's a dot, and here's a dot. Let's see how much that goes up. 1, 2, 3, 4. So up 4 and over 1, 2, 3. So 4 over 3 does not reduce. Check out the calculator over here. 4 over 3 stays 4 over 3. We just have to remember to put the x behind it. So anything here, let me go ahead and emphasize, anything in this area, these are all solutions. Anything in this shaded area. The line, however, is not a solution. So I'm going to write line, not solution. And that's because it's broken. If it was a solid line, it would be a solution. So the solutions are infinitely many in that shaded area. For example, this point right here of 2, negative 3, that's one of a bajillion answers, okay, that makes that inequality true. All right, so that was, just to go review, this was a chapter, I think you did this in chapter 4. You did this stuff in chapter 5. And then this is another chapter 4 example, okay? So we're talking about functions. It says, let's say we have a function of x, which simply means that after the equal sign, you're going to see x's, and this would pass the vertical line test. What is f of negative 2? All this means is to plug in negative 2. Now, I should say substitute in negative 2. That's the real way to say it. Substitute in negative 2. So I'm going to do a negative 4. I'm using my equation. If you're like, what equation are you talking about, Langeli? I am talking about this equation right here. Okay, I'm going to plug in negative 2 in for those x's. So you see these x's that I'm highlighting in blue? I'm going to plug in negative 2. So instead of x squared, I'm going to put negative 2 squared. Instead of 10x, I'm going to do 10 times negative 2. That black highlight was horrible, wasn't it? So for emphasis sake, negative 4 is negative 4. X became negative 2. Squared is squared. Plus is plus. 10 is 10. X is negative 2. Minus is minus. And 3 is 3. So I just wrote the whole equation and I changed all the x's into negative 2's. Okay. Your calculator can handle this in one big step, but just in case this is not a calculator problem on the keystones, I'm going to walk you through by hand how to do this. You would do your exponent first. So you would do negative 2 to the second power. Negative 2 times negative 2 is positive 4. Everything else would drop down. Negative 4 times 4 is negative 16. 10 times negative 2 is negative 20. So you do your, please excuse my dear and silly, so I'm doing all the multiplication there. Now I'm going to do 6, add negative 20, that's negative 36. And then negative 36 minus 3 is negative 39. But just to prove to you your calculator can handle this in one step, take a look. You have to use parentheses. We've discussed that back in chapter 7 with negatives. And you can see negative 39 is what you would get. So you can say my function, if I substitute in negative 2, equals negative 39. And that's how you solve that problem. So that's it. So today you learned how to multiply and divide. Please remember, don't skip the steps. I know like this one was the only one that like the step actually worked out really well. But remember, no matter what you do, if you trust my process, if you multiply them and then you use your list, it'll always work. Okay, I promise. If you multiply them and then you use your list and my method, it will always work. Division's the same way. If you divide them and then you use the list, I promise you it will always work. All right, and we'll see you on the practice problems.